All right, y'all got some problems here, kind of build where we left off yesterday. Or hopefully you wrote down these statements though, but I want to make sure we have time to get through and ask questions as we work on them. So as we talk about circles, right, things that we're focusing on is what happens if like they're within the coordinate plane, right? So talking about line segments, we're thinking of the diameter and the radius. I just was general here and said line segment. The midpoint is also important because that's going to talk about the center of a circle. Okay, those are going to be some things that are important. So I want to focus on as we work through this. As we see here, this first one, if I put it in the form of a circle, it could be like, hey, let's find a diameter instead of just a line segment in general. And the 2 points represent the endpoints of that diameter. Okay. Now for this problem though, I asked us to find the midpoint. How do I find the midpoint? Right. What do we do when we add something and then divide by 2? So we add 2 numbers and divide by 2. All right. So remember, whenever you deal with the midpoint, we're definitely adding the values and dividing by 2, but make sure you keep in mind that's just an average. All right, say you're looking at the test grades for your class here right now. To determine your test grade for the overall grade, you have to use the excuse me. You have to use the average of the 3 tests we've taken, right? So you add up all your grades, divide by 3, and that'll give you the average. Now, midpoint is the middle of 2 points, right? So make sure you see your average the X, you average the Y's, and that'll give you what we're looking for. Now, the nice thing about this one was the X values were the same already, right? So the average of 3 and 3 should be 3. Make sure you keep that in mind as kind of reassurance. And then halfway between 1 and 5 is 3. So just kind of looking at the graph, we could have picked that up just kind of by a quick glance, which would have been fine. So by a quick glance of having a graph available, you can kind of see, okay, it looks like it's 3, 3, but not everything is going to be that straightforward. Work out to something nice. I just felt like that was a good place to start to highlight, hey, don't forget if both X values are the same, the average of those is the same number. Okay, that's how the midpoint works as averages. Now you can just memorize or write that formula down, but the key is just to go back to the basics. Like, hey, I have 2 points. A midpoint is the middle of those. And that's where average or mean would be another word you might hear come in to help. Are we good with where that's coming from? Now for our context, right, we're working with circles. So make sure you see here, like as we point out that point here, that is the center, right? So we would say, hey, like this is the center, and the center would be at 3, 3, as far as an ordered pair is concerned. So the next line segment, though, I said find the distance. All right. Now make sure as you look at this one, the distance I'm focusing on is going to be a diameter. All right, that's the example I've given here. So I could say like, hey, find the diameter when the endpoints are these 2 points. Okay. Well, to find the distance, what did we use to help us build the formula? We don't need the slope. The slope, I talked about slope, right? Slope was just there to help kind of say, don't forget that's something we might need to find. What formula, though, did I use to kind of start building that perspective? So if I zoom in on here, right? The whole idea was I built a triangle, right? We have A, B, and then that would leave D to be our hypotenuse, right? So the Pythagorean theorem helps us there. Now, just keep in mind, though, we do have 2 points. So we would say here that the diameter I'm looking for, and D's for distance in this case, remember, as I said, for the context of a circle, I'm just putting D for diameter. We want to use the square root. We don't want C squared, we want just C. Now, the part that we have to remember is I have 2 points. So first you have to find the distance between X values. So we'll say X2 minus X1, and then the distance between the Y values. Right? I'm putting in parentheses though, because the Pythagorean theorem says you have to square them and add them together. So that's where the A squared plus B squared equals C squared perspective comes in. Now, just help remember the pieces though. When you do this here, you're just saying, how far is it from here to here? That's where that comes from. When we do this one, the same thing. How far is it from here to here? So that's what builds the sides of the triangle. That we're not looking at a triangle, but we're using it to help us here is the key. So in this problem here, we would get X2 minus X1 plus Y2 minus Y1. So what does that give us? 3 squared and 2 squared? So it gives us the square root of 13. Now, the way that we interpret that is, hey, from this point all the way over to that point is a distance of square root of 13 units, right? In our case, it was just whatever unit we want to use. We're not going to focus on the units right now, but just make sure you keep that in mind as we deal with this. Units do come in at some point. With that said, then, just to make sure we're good, what would the radius be? So if I look at this and say, what is the distance of the radius? How would we find that? So we have the diameter, right? How do we get from a diameter to a radius? So we already got the square root, right? But it's what? It's half, right? So remember, it takes 2 radii to make 1 diameter. So the radius is half of the diameter. So make sure you're careful with that. Now, this doesn't look nice, right? But this was just me practicing the formula. Okay. Sometimes it'll work out to an integer value. Sometimes it won't. Always pay attention though, because the context I gave you here, as far as the circle is concerned, I forced this one to be a diameter, right? So that was just the way I decided to set it up. So I gave you a general statement. Let's make sure to look at it in the form of a circle. Any questions there? We feel okay with those? All right, so this is one example where, hey, we need to do the work to find the equation of the circle, okay? The work we should be expected to do. If they give me points and say, give me the equation of the circle, be ready to use midpoint and distance to do so, okay? Now, as far as the circle is concerned, make sure you see here that we're going to use that general form, x minus h squared plus y minus k squared equals r squared, where the center of the circle is at h comma k, and the radius that we're looking for is just the r value. Now keep in mind it's r, not r squared. That's where the square root comes in. Now, what did this problem give us right off the bat, though, that can be helpful? They gave us 2 points. What was one of the points, though? 45. All right, but that's the center, right? So we have a lot of information already. We can actually go start forming our equation and say, hey, this is x minus 3 squared plus y minus 5 squared. All I need to do now is go find my r squared. Keep in mind, that's not always going to be the case. As we saw with the previous two problems, you might have to use the midpoint to get the center, right? So that first problem would be example where, hey, now I have the center. Let me go plug it in after using the midpoint. Now, with that, though, I said one of the solutions is at 910. What does that mean? Right. So let's go try to do a quick graph just to help get us a general idea of what's going on. All right, so the points that we have here, we're at 3, 5, and 9, 10. Now, 3, 5, though, we have to keep in mind is actually the center of our circle. Oops. So the circle is going to look something like that, right? What measurement would the distance here give us? That's going to be our radius. Is everyone clear on that? So that means that, hey, I got 2 points. The solution is on the circle itself. That's what it means by a solution. Because when we talk about a circle mathematically, we're just talking about the outline of the circle, the outer edge. That's what we're looking at. Okay, so when it says solution, understand that that's what it's referring to as far as a solution. So with that said, then we can use the distance formula here to get the radius that we're looking for. Okay, just make sure you see there the 2 points that we'd use would be the center and the solution. So using that distance will give us our radius that we need. And I'm not going to write the formula down again, but make sure you go back to the previous slide to make sure you see that, hey, I'm using that same formula to get to this information. So what's 61? Not necessarily the nicest number, but 61, we're not gonna be able to simplify, right? So don't worry about that. Do know that oftentimes on the homework especially, you should be able to simplify. On the test, there's different perspectives they give you typically on the test. So it has been kind of a mix, whether you're stuck with the radical or you can say, hey, like the square root of 64 is 8. Okay, sometimes the integer values do come about. Now, with that said, though, we didn't want the radius just to have it. We want this radius because now we can give the whole equation that we were looking for, and we would actually be done. So we have the x minus 3 squared plus y minus 5 squared, but what do I need to put on the other side? Do I want r or is it something else? So we have our radius, but it wants what? R squared, right? So what's the square root squared? It'd just be 61, right? This is one thing that I would just be careful with circles, right? Make sure you remember as you deal with circles that this is r squared. You have to take the square root to get the actual radius's length. Okay. I know my drawing isn't perfect, but that was just to highlight, hey, we have the center and the solution is on the circles itself. Question? Now, the one thing, as I said here with this one, make sure you take into consideration the first two we just did. Right? This one, I gave us a radius. Right? Both of these, though, I gave an example that has a diameter. So here, you need to use the diameter in the midpoint to get the center. So this would be an example where you have to actually get the center yourself, whereas this last one, I gave you the center. This example is, hey, not only would you have to get the center, but you have to find the length of the diameter. Now, I put at the very end, though, make sure you understand, once you get the diameter, the radius is just half of that. Okay, make sure you keep that in mind. This is putting it all together. I just happen to use a radius. I gave you the center already to save one step at least. Okay. Any concerns, though, with how those can be applied in these situations? All right, so the next step then is let's look at the equation and make sure we can still identify the center and the radius. So write down these three equations and make sure you leave some room below the last one. The last one's going to require a little work from us. All right, so this is one of those problems that just kind of goes with like graphing with transformations, right? If you can make sure to remember and recognize the pieces, it can be a nice straightforward problem, but you have to make sure to remember what we're working with. As you look at these three problems, what does each problem have that tells us it's a circle? Exponent. Specifically, what exponents do we see? A 2. And where is the squared at? With what variables? Make sure you see here you have an x squared and you have a y squared, right? So understand that a circle is always going to be x squared plus y squared equal to a constant value. Okay. Down here, it's very important that we see that. That's kind of what we see here. This is more of a general form rather than a standard form. I think I mixed them up when I said that. We like this form here because I can get to the center and the radius. This is more of the general form, but the key that you need to see here is, hey, it's positive x squared, positive y squared. What's in front of the x squared and the y squared? Nothing, right? Understand that's important as well. okay? Just to kind of make sure we highlight that if we kind of go look at a quick graph. Let's get out of that though. All right, so I just picked x squared plus y squared equals 16. We get a circle, right? If you change something and put something in front of x squared and y squared, let's look at what happens. What did it do to my graph? It's now an oval, right? Or what we'd call an ellipse, right? But the idea, it's no longer circular. Does everyone see that? How the inside, there's actually kind of a shrinking that takes part. It's kind of what you see there. Now, what we'll see when we do the work with that last equation, we'll kind of understand what happens there. Now, we didn't need to know this, but make sure you understand the importance of having one x squared and one y squared, no coefficients. Okay, that's definitely all I want us to see here. Now, with that said, though, what's the center of the first one? All right, why would we say 0? It's just y squared, right? Does everyone see that? That means there's no vertical shift here. There's 0. Okay, what is the radius though? Why is it 11? What do we have to do? All right, so we have to remember r squared is 121, right? So r is the square root of that. That's very good. That is definitely one part on here. Be careful, because guess what? On a final exam, what are they going to put? Both of them, right? Usually a well-written multiple choice problem will put both of the answers, 5-0 with 121 and 5-0 with 11. Now, I will say with this, the multiple choice problems on this test are, I would say, medium difficulty, in the sense that usually you can eliminate down to the right answer, right? So if you're comfortable with the material, make sure, as I told you on my test, eliminate answers that you know are wrong and then move forward. Okay, so like this one, the first thing you should go scratch off is every answer that has 121. Is that clear to everyone? Remember that. Make sure you remember, no, I got to do the square root, scratch off those other ones. And then you might find out the other two, one makes no sense at all, right? So that's going to be the helpful part there. Make sure you use those test taking strategies, not just the math skills, but the how can I make this easier on myself? Okay. With that said, what is the center of the next one? Are we all comfortable with it being -3 and +2? Hopefully you see again, like I said yesterday, I think it was the connecting back to the vertex, right? We had to do the opposite of H when it was in the vertex form. The same kind of things going here. Now be careful with this one. The radius is the square root of 24, right? But technically speaking, we should write that as 2 squared to 6, right? Because 4 times 6 is 24. And the square root of 4 is 2. Okay. Now on a final exam, the good news is if this is a multiple choice problem, put it in the calculator. If you know it's supposed to be the square root of 24, put it in the calculator. Okay. Now the good news is I kind of gave away what to be prepared for, right? Either you're going to see 24 or something with the square root involved, right? The square root might be a good hint, but just always double check, right? Use your calculator, do a quick check on the what's going on. Okay. Any concerns with these first two? To me, as far as final exams are concerned, problems like this one and these first two definitely have been used more often. Okay. Lately in this test, it's been focused on this part here. So make sure with this one, this is the assignment, right? Make sure as you go through the assignment, the first 3 slides I did today would focus on the assignment. I feel like this is fine though for a final, because we need to make sure to know how to identify these stuff, right? What's the problem with this third one though? It's not in that nice standard form, right? Well, what did I tell us that you're going to have to do at the end of the semester, no matter whether you like it or not? Completing the square, right? What happens here is now we have to not complete the square once. I have to do it twice. Okay. So what you're going to see here is taking kind of what I did before. Anytime you have something in the general form, right, for a circle, and we know it's a circle because it's 1x squared and 1y squared added together. They're both positive, right? Start isolating the variables together. So I'm going to do x squared minus 8x. I'm going to leave a space and I'm going to put y squared plus 6y. I'm going to leave a space. And then remember that 11, we just move it to the other side. Right? Constant term, we can move the other side because it's the same situation we were with quadratics. Now, make sure you see here, though, we have to complete the square twice. So what are the two numbers we're focused on?
8 and 6.
Right? So what we want to do here is say, hey, I'm going to take half of -8 and square it. And then I also want to take half of the 6 and square it. Now, remember, the idea of half is we want two factors that are the same, right? So when you just break it in half, we're good there. But the reason we need to square it is because that's what we're going to put up here. Okay, we need to do the squaring part to make sure we build the equation to factor. With that said, though, what half of 8 is 4. So -4 squared, well, that'll give us plus 16. Just make sure whatever you do to one side, do to the other as well. And then for the 6, we have half of 6 is 3. So that's going to put plus 9 on both sides. Now, the whole point of doing this is to factor them. That's the one thing I hope that throughout the semester, whenever I've done completing the square, you remember the purpose of this is to factor. But what two numbers multiply to 16 and add to 8? Well, that's where this comes in, right? And that's where that comes in. That's why we have that process there, just kind of highlight like, hey, the whole point of this is to force it to factor. Okay, so when I go in and to factor this, I'll get x minus 4 squared plus y plus 3 squared equal to what? 36? Now, with that said, you could have kind of seen the center from the beginning anyways, right? The 36 is the part we have to complete the square for, right? As long as you remember, take half of b, you would have seen -4 and 3. You just have to remember, hey, take the opposite of that for the center. So make sure when you do that, your center is +4 and -3. But when you look up here, that's just half of those. Now, the reason why we need all this work, confirm that we factor, but more importantly, that gives us our radius squared now. We don't want 36 though. What is our radius? Now, the good news I will say with this, for like the problems that you have to complete the square here, you won't have to worry about anything but 1 being in front of x squared and y squared, because that's what a circle is.
It was what two numbers add to get what? Like, remember we did -4 plus 3, like.
Oh, so remember, I just took this to get here,
Oh, okay.
right? But once we get this in place, we can factor this trinomial. So what numbers multiply to 16 and add to -8? And that's where this comes from. Now, keep in mind, it's the same thing, right? The whole point of that is always going to be 4 and 4, in this case, 3 and 3. Just be careful here to see we need to keep the sign as it is. So like this one needs to be -4 because it was -8. And this one needs to be +3 because it's +6. Okay. Now, keep in mind, again, as I've said before, I've shown the 3 different situations to be prepared for, right? Be prepared for a problem where you got to find the distance. You have to use the midpoint possibly to get to the equation. One, it could be the equation and you have to interpret it, okay? Which hopefully you took my hint today on what to be prepared for the final. The last one is you have the equation, but we have to manipulate the equation to get it into that nice standard form. That's where completing the square comes in. The same with quadratics, right? We completed the square to get it into that vertex form. The same here. Now, the reasons it's nice for circles, because again, it's just x squared and just y squared. Nothing's in front of them and they're both going to be positive, right? So I can jump straight into that aspect. So it's actually a little bit nicer than the quadratic aspect. Okay, so keep that in mind. The other good news is make sure you remember for the quadratics, you had the alternative, right? So make sure you go back to what we kind of talked about the other day, like the vertex, you can use h equal to -b/2a. My hint here was, make sure you see here, it's the opposite of b/2, right? A is 1. So there's still similarities, But make sure you see like, hey, it's half. It's half, right? There's still similarities. It's not exactly the same, though, so we have to be careful. With that said, let's look at another. Now make sure you see here again, this is in that general form, right? So I can't get to everything right away. 6 and 5, though, hopefully is something that we're looking at. Hopefully you're jumping to 6 and 5, though. That is an important aspect. With that said, though, what will I do first to help get to that standard form? Start isolating things together, right? Let's get the X's together. Let's get the Y's together. And let's get that 44 out of the way. Just make sure, remember, when you move to 44, we have to change the sign, right? Don't forget. But as we saw before, this is where we can then use the only thing that's left, right? For the X's, all I have is 12 to work with. Just make sure you remember when you put plus 36 here, do it on the other side as well. And then for Y, you get 25. Is it 17, y'all? My brain.
Yes.
Okay. I need a break. But a couple weeks now.
Just put 17.
Yeah. 'Cause it was small.
Yeah, but keep in mind though, like the 17 is a part of the equation, right? So the
Yeah.
next step would be like, hey, center. What do we have to remember about those values though for the center? Opposite signs, right? And then the radius, like you said, just put square root of 17, which at the very beginning, y'all make sure you hear me what I said before, even with that square root of 24 there. Put the square root of 24. If you remember how to simplify it, that's perfect, but make sure you get the square root of 24 first. Okay, square root of 17, thankfully, there's nothing we can do with that, right? That just leave it as it is. Now, you know, moving forward, no, you put in your calculator and get the decimal, right? For us, just leave it as it is.
Where did 17 come from?
That was starting with that negative 44, right? And then where the 36 and 25 added to it. So once I put all those together, it gave me 17. But that's definitely where the importance of this process comes into play. Okay. But hopefully what you see, the nice thing about it is just remember, take half of it and then multiply the number with itself. That's the whole point of that. If you need to, one of the things I recommended was write out the factors and then multiply it to see what number goes here, right? If you multiply that out, you'll get the x squared plus the 12x, and then you'll get a plus 36 that you have to then be like, okay, that's what I put here. All right, so keep that in mind. But that's where it goes back to just reminding y'all, hey, we're just factoring, right? We took something that had two variables, nothing really nice as far as factoring is concerned, and we forced it into a situation where we can factor it. But the reason we like that factoring is now we have 1x, 1y, and the exponent's outside parentheses, right? So we can use that information to help us. And that's where the center definitely comes in to be helpful, right? If you think about drawing a circle, what tool do we normally do to help draw a good circle? And then it looks something like this. And over here, you had your pencil. The compass, isn't it? All right, you put this at the center. You set the distance of the radius and you just had to spin it. You get a perfect circle, right? Questions or concerns with this one? Do we feel okay with these two though, for like as far as the assignment is concerned? And hopefully what you saw there, like getting to the center, right? We could see kind of from the beginning. It's the whole reason we have to do the process, so is get to that radius. That's definitely the important part there, right? We're going through all that to get to that radius. Any questions about the work today before we finish up? All right, well, that's all we have for today. We're just a couple minutes early. All right. But please make sure you remember what I said as you go to the assignments. Do your best on the assignments, right? But as far as the assessment is concerned, you have to be able to interpret that equation, right? So whether you have to complete the square first or not, we have to be able to do this part. That's the key. Everyone good with that? All right, well, the last thing then, before I close out, let me shut off Zoom.